In this lesson, we're going to go over some matrix basics. Specifically, we'll understand matrices, we'll determine the order of a matrix, we'll write a system of equations using a matrix, and given a matrix, we'll be able to write the corresponding system of equations. So matrices, which is the plural of matrix. There's an example for you in the white box. A matrix is a rectangular array of numbers, or another way to think of it is a table of numbers. It consists of rows and columns. So the rows go this way, and the columns are vertical. Okay, so the order of a matrix is determined by the number of rows, and then we use an X by the number of columns, or M by N. Okay, so in this example, there are 2 rows and 3 columns, so the order would be 2 by 3. And then matrices are useful because they are a way to solve a system of linear equations. So in the previous few lessons, we talked about solving a system of linear equations in 2 variables and 3 variables, and we were using substitution or elimination. Now with matrices, we'll be able to solve them using other techniques, which we'll go over in the next lessons. But in this lessons, we're just going to get acquainted with matrices. Okay, so example 1, determine the order of the matrix. So remember, the order is row by column. Okay. So in this first example, there's 3 rows, and there are 1, 2, 3, 4 columns. So the order is 3 by 4. It must be written row by column. Okay. In the second example, there's 1 row, and there are 1, 2, 3 columns. So this order is 1 by 3. And in the bottom, we have 2 rows by 2 columns. So this is 2 by 2. Okay, so when the number of rows match the number of columns, it's called a square matrix. Okay. So next, augmented matrices. So an augmented matrix can be used to write a system of linear equations. So there's a vertical line that represents the equal sign in an augmented matrix. So take a look at the example. We have 2x minus 3y equals 7, x plus 4y equals negative 2. So this is our system of linear equations, but we can write it as an augmented matrix. Okay, so each row is an equation, and our columns to the left of the vertical line represent our variables. So in this case, x and y, we have the vertical line, which would be or replaces the equal sign in the system, and then we have 7 and negative 2. Now, one thing to note is to form the augmented matrix is we're only taking the coefficient or the number in front of each variable. So instead of 2x, we just wrote 2 because it's understood that this column is the x column. Negative 3y, we just put negative 3, equals 7, so vertical line 7. And same thing for x plus 4, there's just 1x, so if there's no number in front of x, but it's there, it's just a 1, plus 4y equals negative 2. Okay, so let's practice converting from one form to the other. So example 1, write an augmented matrix for the following system of equations. So I have 3 equations. So that means I'm going to have 3 rows, 1, 2, 3. I have 1, 2, 3 columns, my vertical line, and then my other column. So 4 columns total, but 3 to the left of the equal sign. So I'm going to start to build this. So we have our variables given are x, y, and z. Okay, so the number in front of x in the first one is 8. The number in front of y is negative 2, and the number in front of z is 2. And that is equal to negative 6. So this first equation becomes our first row of the augmented matrix. For the second equation, the number in front of x is 7, the number in front of y is negative 5, and the number in front of z is 1, and this is equal to 7. So my second equation is my second row. Okay, and then let me find a new color. So here we have no x's at all. So this is a case where x is equal to 0. Just like in the equation before, it was just z, so that's understood to be 1z, but x is completely missing from the third equation, so that would be a 0. The number in front of y is 1, the number in front of z is negative 5, and that is equal to negative 7. So this is how you would convert this system of equations into an augmented matrix. Let's go the other way around. We'll write the system of equations that corresponds to the following augmented matrix. Okay, so we have, this will be x, y, and z, and here's my equal sign. Okay, so for the first one, we have 1x plus 0y minus 3z is equal to 16, which is another way of saying x minus 3z is equal to 16. For the second one, we would have 2x minus 4y plus 7z equal to 23. And then for the last one we have, oops, my color didn't change. 8x plus 1y minus 4z is equal to 8. Okay, so I'll circle the three equations that correspond to this augmented matrix. X minus 3z equals 16, 2x minus 4y plus 7z equals 23, and 8x plus y minus 4z equals 8. Thank you for watching. If you have any questions, please feel free to reach out to me.